Dear friends of Beston, welcome to my show. I'm Fred Wang, and today is 7th September of 2021. Today we are at one of our operational site of our carbonization plant. I'm going to take you inside to see the machine in real. And before doing that, I would like to give you a brief about this project. The raw material they are using are sawdust and wood pellets, and the capacity of which is 1 ton per hour by input and 300 kg output of charcoal. Now let's move our steps and move inside. Now we are inside and you can see the overview of this plant. And before we start to walk you through the step after step from the beginning to the end, we first will talk about the raw materials. For our carbonization plant, we can take 3 kinds of raw materials. For most cases, we will take biomass. Biomass carbonization is to convert the biomass into charcoal. It can be made for barbecue, for shisha coal, or even active carbon with further process. And the second kind of material we can take is the sludges. The sludge are mainly drainage sludge, which contains a lot of organic. The purpose of that is mainly for disposal, to get the tipping fee from government. And the last kind of material it can take is the waste plastic. The waste plastic carbonization will turn the waste plastic into the solid fuel for burning in the later. And after the type of materials, there are also several requirements for our system. Because we have a continuous system, so the 2 requirements of the raw materials are there. One is about the size. We require the size to be less than 20 millimeters. And if your material is bigger than required, we will equip the crusher for you. And second is the moisture of the material. If your material appears to be more wet than required, the moisture requirement is 15% by moisture. So if your material is more wet, we will equip dryers for you. From 15% to 45% of the moisture, we will equip 1 dryer. From 45% to 70% of the moist, we will equip 2 dryers for you. And once you have a project and you're specific about the material and capacity, we can already make a proposal for you. Now let's move to the process. To start with is the feeding process. The feeding is being done together with the hopper and the belt conveyor. The combination of the hopper and belt conveyor makes sure the material will be fed inside steadily and constantly. The conveyor we are using are big angle belt conveyor with compartments, you can see, so that the material will be fed inside steadily and spread out in a uniform way. After the feeding, the material will drop into the next section. The next section will either be the reactor itself or the dryer, depending on the project itself. For example, this one, they don't have a dryer here. But for instance, if you do, the material will first drop into the dryer and go one way up from front to the end and drop to the next belt conveyor to be transported to the reactor. The dryer that we are using are heated by the hot smoke generated from the combustion chamber under the reactor system. And the hot smoke will go through the dryer and finally reach to the dedusting system. And inside of the dryer, we have a structure called scatter shaft. The shaft will throw the material into the air to have a fully touch with the hot smoke, so to effectively dry out the material. At last, the material will drop from the top of the belt conveyor to the airlock valve. The utilization of airlock valve is to make sure that no air will come into the system. So we install this device in every exit and entrance of our vessels, including reactor and the dryer. Now behind me is the main body of our reactor. In Beston's design, the reactor will reach to the continuous function, the mechanism of which is to keep feeding and keep discharging. The entire time that it takes from a material entering into the system, from entering to the discharging, will take only 20 minutes. To reach to this goal, we have two major know-hows. One is the double tube reactor design, and another is the double combustion chambers design. First, we will take a look at the reactors. The material dropped from the top of the belt conveyor into the reactor. First, it will drop into the inner tube, and then it will travel all the way from the front to the end, then drop to the outer tube. Then the material will travel back from the end to the front again and being discharged. So feeding and discharging are from the same side. And the reason why we take this design of double tube design is to save space for the traveling. So the traveling route will be very long, but the space needed is very limited. And second, we applied this double combustion chamber design. It has two benefits. One is the reactor will have 3-point support. So there is extra support in the center of the reactor so that after a long time use, the reactor will not be deformed. And the second is the two chambers can be manipulated by PLC separately. So the temperature inside will be different. So to make sure the carbonizing will be fully done. At last, material-wise, our reactor will apply the 310S stainless steel in the fire zone. Like I said, we have two combustion chambers, and in each area, the reactor will be made by the stainless steel, so that the lifespan of our reactor will be 8 to 10 years. And after that, a simple reinforcement of the reactor will make it last longer. After the reaction, the material, which is now charcoal, will be discharged from bottom of the socket. With two cooling dischargers, it will reduce the temperature to less than 35 degrees centigrade. Then you can choose to use the briquette line or the shisha making line to make it a shape, or you can simply store it. But tips are, because there is still the piling temperature, so please store it in a closed environment. During the process, the syngas will be generated. The syngas of our system will be outlet from the top of the socket, and then it will transfer to the cyclone deduster to remove the dust, then a hydroseal to balance the pressure and prevent the backfire from happening. Then the syngas will be direct back to the combustion chamber for burning. So the heating is provided by the syngas after preheating. That means the system is self-sufficient, and after the preheating for 2 hours, then for the entire next week, you don't have to use your own fuel. The hot smoke from each combustion chamber will come out to our dedusting system. If there is a dryer, the hot smoke will first go through the dryer before it reaches into the dedusting system. If you do not have a dryer, it will go direct to the dedusting system. The dedusting system consists the cyclone deduster to remove the particles and dust. Then it has a spray tower. The spray tower consists of ceramic absorption and water spray. So at last, when the hot smoke released to the air, it will be mainly hot vapors. With our PLC system, we can achieve the smart control. For example, when the feeding material's temperature and moisture become bigger, and then the system will recognize and adjust the temperature in the combustion chamber, so to secure the carbonizing will be fully done. In this way, the managing labor will be saved mostly, so you can grab a cup of tea and enjoy your afternoon. Now we are seeing the drying system that our customer equipped by himself individually from our carbonization system. I will walk you through the process. First, the feeding will be done by the belt conveyor. The belt conveyor will transport the material and drop it into this trump screen. The screen will separate the big matters and the small matters. The big ones will be taken out for crashing, and the small ones will drop to the bottom, and another belt conveyor will transport to the silos. And those two silos with the screw feeder will feed the material separately into different dryers. And after drying, the material will be sucked out by this big pipe and into the cyclone deduster and another silo here. And similarly, from this dryer, the material will drop from there. This two port will discharge the dried material and transport it out to be stored.